Larry Mitchell is going to give us a talk on Sir William Herschel, and who best to give us a talk on the greatest astronomer of all time, and one of the greatest astronomers of our time. So Larry's got a lot of accomplishments. He has his own catalog known as the Mitchell Anonymous Catalog. And he has an asteroid named after him, which I believe our own Joe Dillinger had something to do with. Discovered supernova 1944S, is a chairman of 2 star parties, and also has a new book coming out. So should be pretty exciting. So without further ado, Larry, let's get you switched over. So we want to go ahead and get you going here. Start the share.
Great, appreciate you guys. Let me start early. Can y'all hear me?
You want to stop the sharing?
I usually don't have a problem being heard.
You have to hit stop sharing.
Okay. Yeah. While he's setting that up, a few things about William Herschel. He is one of the most underappreciated astronomers, I think, of all time. Most amateurs know him of the Herschel 400 observing program. A few more know that he discovered Uranus, the planet. A few more may know that he discovered infrared light, but that's about it. People don't realize that he, in the mid-18th century, 1750, 1760, he completely changed astronomy as the so-called experts knew it. Isaac Newton dictated the laws of the universe at the time, and he had a law that he called a God the clockmaker, or a clockmaker God, if you will. And his theory and the professional astronomers of the day, all they observed and studied was the solar system, the planets. And like a clock, like Newton's clock, the hands of the clock were the planets that revolved around the sun, which was in the middle of the clock, but the background was static and it never changed. Never moved. Nobody ever looked at the background, at what we call deep space. William Herschel, by himself, by his intellect, by his visual acuity, completely changed all of that. So I've got a lot to talk about, so I'm going to race through a lot of it, and hopefully I can get this done in some short fashion. Herschel grew up in a house of music. His father was a musician. His father joined him, got him to get into the Hanoverian Guard at the young age of 14. And Herschel was in a war, in a battle called the Battle of Hastinbeck, which was part of the 7 Years' War in France. We call it the French and Indian War over here. And he was armed with a fiddle. And bullets were flying around his head, and he decided that's a bad idea. And since his father had never installed him officially in the army, he left Germany and moved to London with his brother Jacob. And for a period of time, they wrote music, they fixed instruments, they played in little parties and things of that nature, made enough money to get by. But Herschel being, when he arrived in London, he had no money. So he was very money conscious his whole life. And he realized that all the money in England was in Bath, or Bath, as the Brits call it. And that's where the aristocracy went to play, and that's where they spent all of their money. So he and his brothers moved to Bath and set up very similar to what they had done in London. But Herschel worked his way up where he was the head music director at Bath and making a very good income. In 1773, because of the lure of mathematics and music, that attracted him to astronomy. And he started building telescopes because he couldn't find a telescope that to hire, as he put it, to rent to his liking. And within a year, he was building the finest telescopes that ever been built. And he was very good at it. But as far as astronomy, he didn't take up the science of astronomy until half of his life, until he was 35 years old. Before that, he was a musician. This is where he lived in Bath. It's at New King Street. Today it's a museum. The backyard of this building, which is very small, is where he discovered the planet Uranus. And today, if you took the cars out of this street, Herschel would recognize this street. It hasn't changed a bit since the time when he lived there. And he lived well. These are some of the furnishings inside the house that were there when Herschel lived there. He spoke 5 languages fluently. He only wrote in English and French, never in German. But he was very accomplished at speaking different languages. His other languages were Italian and Latin. And he was also accomplished in 7 instruments that he played fluently. He built his mirrors, which were made out of metal. They were copper and tin. They were called speculum. Speculum is Latin for mirror. And this is some of the mirror making and telescope making equipment that was in his house. Every bedroom, every room in the house was a workshop. He had equipment everywhere. And in 1773, his younger sister came over, Caroline, and she was aghast that the whole house was a workshop. Even the bedroom had lathes in it and stuff like that. The telescopes that he built were incredible. They were the best telescopes ever made. The professional astronomers at Greenwich started buying telescopes from Herschel because his telescopes were better than theirs. And in his lifetime, and this sounds impossible, but he had other people helping him build these telescopes, but he built 73 telescopes. I built one in my life, and that was more than enough. The specula, the mirrors, he did 200, what you call 7 feet. In those days, the telescopes were rated by the focal length, not the diameter of the mirrors. So when I say 7 feet, that's the focal length, how long the focal length of the telescope was. I made 200 mirrors for that. 150, 10 feet specula, 80, 20 feet specula. I mean, those are incredible numbers. His sister, Caroline, helped him grind some of these mirrors. His brothers, Jacob and Alexander, helped him. The king's cabinet maker helped him with the woodwork. So he had help, but still, these are incredible numbers. He recorded 2,160 experiments on how to build better telescopes and mirrors. And these are some of the telescopes made to order that he has in his book. And he was a pretty smart guy. I just highlighted a couple of these things. Dr. Belcher, his 7 foot or 7 feet telescope, which was the one he discovered Uranus with, and his favorite telescope, he sold that for 105 pounds sterling. I calculated back what that would be worth today, and 1 pound sterling today is worth about 192.90 pounds sterling today. And if you take the exchange rate, 1.24, that telescope today would be worth $25,000. That's the equivalent that he was selling these for. So Dr. Belcher paid $25,000, but the Empress of Russia, also for a 7 foot telescope, she paid $125,000. So it must have been a good telescope, but he knew who to charge and how he could make more money off of different people. This is the only replica of one of his telescopes in existence today. It's in Madrid, Spain. And you can see the person down here, give you an idea of how big this telescope is. This was it was sold to the King of Spain, and it was a 25 feet focal length, 24-inch speculum. Unfortunately, it was destroyed in 1808 by Napoleon's troops, but this is an exact replica of the telescope. As far as teamwork and how he built his specula, this was a write-up that Caroline Herschel wrote, but it said this at one time was the case when at the finishing of a 7 foot mirror, he had not left his hands from it for 16 hours. When he ground these metal mirrors, he felt if he ever took his hand off of it, he couldn't feel the curve. So he stuck with it until he finished it. And there's another write-up where he was with one for 30 hours. But he was obsessed with this, and he said in one of his write-ups, he says the undevout astronomer must be insane, you know. He was about as driven as anyone has been in the history of the science. This is the backyard on King Street where he discovered Uranus. It's very small. My friend Stephen O'Mara was over there in 2004 and sent me some pictures of this, knowing my love of Herschel. The backyard was very small, and he never really stated where exactly he had the telescope when he discovered Uranus, which he called Georgium Sidus. He knew how to schmooze up to the king. Georgium Sidus means George's planet. And George III was the king of England at the time. So he throughout his life, Uranus was called Georgium Sidus. That was the official name for it. This is his write-up of his discovery on March 13th, 1781. And this is in his own handwriting. It said, in the quartile near Zeta Tauri, the lower of two is a curious either nebulous star or perhaps a comet. A small star follows the comet at 2/3 of the field's distance. The vertical lines means that Carolyn had entered this in another sweet book elsewhere, and that means that they had officially entered it. But the interesting thing about this is Uranus had been previously plotted as a star on 20 other star charts by other astronomers, other observers. John Flamsteed, who was the first astronomer royal, gave it a star number, 34 Tauri, Uranus. Messier later asked Herschel, how did you know that this was a planet? Because it didn't move at night. And Herschel's answer was because of its appearance. And those of you that have looked at Uranus, it doesn't look like a star. And the other thing was, and this is the telescope that he discovered it with, but the other thing is that when he looked at it and put magnification to it, it got bigger. And as we all know, if you increase the magnification of a star, it does nothing. That led Herschel to believe it was a comet. He had no idea it was a planet at first. He called it a comet at first. This is the 7 feet telescope, 6.2-inch aperture that he used to discover it. And of interest is, where am I? Of interest is the eyepiece holder. It slid back and forth, up and down the tube, without adjusting the eyepiece. And the reason for that is that when you repolish the metal speculum, you change the focal ratio of it. So by moving this backwards and forwards, he could correct for that, which is pretty neat. He had 10 specula made for this telescope, 4 diagonal flats made. And as I say, this telescope, if today's price would be a $25,000 telescope. And he had people standing in line waiting to buy these things from him. They were so much better than anything else. Not a comet. Star diameters do not increase with magnitude, with magnification. Neville Maskelyne, who was the astronomer royal at the time, and started out making fun of Herschel with his by him being an amateur and writing about this stuff. Later in life, Maskelyne and the other professional astronomers were waiting for Herschel to tell them more, because he was so far ahead of the rest of them, because he thought for himself. It was not a static background, which I'll talk about. But Maskelyne calculated out that it was a planet, not a comet. It had circular orbit, not an elliptical orbit like comets. And it had no tail or beard, as they called comets' tails at the time. This made Herschel famous. He was known throughout Europe as the foremost astronomer, the foremost scientist in the world. The king made him the astronomer to His Majesty, and he gave up music completely. Just stopped playing all of his musical instruments and devoted all of his time, full time, to astronomical endeavors. He said, I employed myself entirely in astronomical observation so as not to miss a single hour of starlight weather. And my leisure hours in the daytime were spent in preparing and improving telescopes. I don't know how he had time to do what he did, but he did. King George III was a tragic figure later in life, but as a young man, he was very smart. He loved astronomy. Herschel made 10 telescopes for the king for his own use. George appointed him court astronomer and gave him a salary of 200 pounds sterling a year, equivalent to almost 48,000 in today's dollars. But he had to move from Bath. He had to be near Windsor because the king wanted to come over and look through his telescopes, and the king wanted to have his friends come look through the telescopes. And that was an endless parade for the next 20 or 30 years of people coming from Windsor, or Herschel had to go to the castle. The king started donating money for a large telescope, which I'll talk about. Initially, he donated 2,000 pounds. Then he did another 1,000. Then another 1,000 because Herschel kept building mirrors that were too thin. They either broke or they bent. And he finally got one that worked for his big 40-feet telescope, which had an aperture of 49 inches. Later in life, about 1790, the king became basically insane. They don't really know to this day what was wrong with him. They think porphyria, which was a mental disorder, but he didn't know who he was, where he was, or anything. And he had enough to keep him worried. He lost the American War of Independence, 1776. He had the French Revolution to worry about. He had Napoleon Bonaparte that wanted to invade his country. So that's enough to make a lot of people nuts. Nevertheless, later in life, he was. This is what he looked like right before he died. So he was a tragic figure. But early on, he and Herschel were very close. They kind of had a falling out about the money, but he was a good benefactor for Herschel. Caroline Lucretia Herschel, or Lena, as William and everybody called her, was every bit as interesting a figure as her older brother William. He could not have done what he did without her, without this little lady who stood 4'3" tall. Someone wrote of her that she was very gentle, very little, very modest, and very ingenious. Caroline was brilliant, absolutely brilliant. At first, she was, because she had some childhood maladies, her mother didn't think she'd ever get married, and so her mother was going to have her as a cheap maidservant for the house. William went to Germany, brought her back to Bath, and initially she was his maidservant in his house, but she became his business manager. She started grinding lenses for him, and she ended up being indispensable to his workings. This is the only known image of Caroline as a young woman, and she wrote down all of his observations. He started building telescopes for her. When they moved from Bath to near Windsor, a place called Datchet, which is 1.5 miles from the castle, there went her career. She had, in Bath, she had become a singer, but she would only sing when her brother played, and she was very good at it. She turned down a professional offer to go to Birmingham, which would have changed her life and made her a wealthy lady, but she told him, no, my brother needs me. So she turned that down. So when they moved to Datchet, William was, well, what am I going to do with my sister? I'm taking her music career away, because he wasn't doing music anymore and she wouldn't sing for anybody else playing. So he decided to make her an astronomer, and she was not enthusiastic at first. She said, I found I was to be trained as an assistant astronomer. I was to sweep for comets. The telescopes that he made for her were all small. This is a small refractor. This is a Hunter telescope in the middle. There's a 2-foot sweeper. They called her comet hunting telescope sweepers at the time. Had a focal length of 27 inches and 30x power, but it was wide field, and she could go from the horizon up to the zenith and back. In about 3 nights, she could cover the entire sky. and she started discovering nebula, which Herschel at this time was looking at double stars. And then she discovered a comet. This had a big effect on her brother. He made her a large sweeper, 5 feet sweeper, of which she discovered nothing. She made all of her discoveries with this telescope right here. Can y'all see that mouse? Okay.
Yep.
I'll see that. Okay. So her astronomical career, like Williams, he started when he was 35. She started when he was 32. Before she was done, she discovered 8 comets. Her brother, as she called William, none. 14 stellar objects she discovered. They were all open clusters except for NGC 891. Beautiful galaxy, 30 million light years away, but she discovered that. She logged all of his observations in the sweep books, the register books, the zone catalogs, the sun and the planets. And people have analyzed this and found in her entire lifetime she made 2 mistakes. Later in life is an older lady. She indexed Flamsteed's star catalog twice, once by constellation and once by right ascension. It took her 20 months to do each one of those, but she sat down and did it. She published her own catalog of 561 stars, and she was the first female professional astronomer that the Royal Astronomical Society and the King paid her £50 a year, which is only about $12,000 in today's money. But she was the first female ever to get paid for doing science, ever. As far as awards, and for a female in those days, this is incredible. She was elected to the Royal Society, the all men's Royal Society. She was the first woman elected. The Royal Irish Society honored her, the Gold Medal of Science, the King of Prussia. And the Gold Medal, the Royal Astronomical Society, is the highest award they can bestow. And John Herschel, Herschel's son, was the president at the time, and he had the honor of giving her that award. So she was quite a lady. And as I say, she couldn't have done, William could not have done what he did without her help. Okay, as far as the telescopes go, William built his first telescope about 2 years after he took up astronomy. He built some smaller telescopes, but his large telescope, this is what he called a small 20 feet telescope. He built this 3 years after he took up astronomy. It had a 12-inch mirror. He observed with it in Newtonian form right here. And he said it could penetrate into space 39 times the natural eye, which is how they looked at aperture back in those days. He used it at both Moth and Datchet. He observed double stars, but he said it was precarious. The latter was precarious and dangerous, which is interesting because it looks like very much like my 36-inch, my 12-foot ladder on my telescope. I hadn't fallen off the top yet. But anyway, he changed and got after he received the money from the King for discovering Georgium Sidus, he invested in a large 20 feet telescope, which 18.7-inch specular mirror. And at first he used it in Newtonian form, which is here. He was looking at the side of the tube. And this was a sweep telescope. People think all of his observers were looking in the front end of the telescope, but that's not necessarily true. He used the Newtonian observing form as much as he used the front view early on. And I'll explain why. He had used 2 new mirrors in this. They weighed 128 pounds each, so he could take them out. A problem with specula is they tarnished at night. And once it was tarnished, it was no good to have to polish it. So these telescopes, he could remove the mirrors. And this telescope here, he used quite a bit. From Datchet, because Datchet tended to flood. It was right near the Thames, and the Thames got high water at times. Herschel moved to a place called Slough, or some of the Brits call it Slough. But this is where he did most of his later life, all of his later life astronomy. And a French astronomer, Francois Arago, said it's the place in the world where the most discoveries have been made. I think that's probably a true statement. And I hope you'll agree with me after this is over. Today, it's a glass enclosed office building erected in 2017. The house was demolished in 1963. And it's too bad they weren't able to save it, or they probably didn't try to save it. This is his 20 feet telescope. This is what he called the front view. This is the 20 feet telescope that he had the Newtonian view on the side, but he went around and started looking through the front. And he built this elaborate platform where he could do sweeps. He could walk back and forth on his platform and do his and move the telescope with the sky as he was discovering new objects. It had a 30-degree sweep on the stand, and he could. And the nice thing about this telescope is he could set it up in 10 minutes or less than 10 minutes. He could find any object in the sky that he knew how to find in less than 20 minutes. He couldn't do that with the 40 feet telescope, with his real big telescope. And this one had a penetrating power of 95.85 times the natural eye. This is the telescope today. It's in the Smithsonian Institution in Washington. And this is a picture I took of it whenever I was up there. It's in the same room with Spirit of St. Louis, but it's kind of in the back. It's behind things. So you have to look for it. They don't have it prominently displayed, but it is the real McCoy. It's on loan from Greenwich. And there's a statue of William Herschel looking in the front end of the telescope the way he did at the time. And then this is Brent Arkinall here over at Greenwich when it was displayed over there. The 40 feet telescope is the one that people most associate with Herschel. This one made him famous. It's the telescope he used absolutely the least. It was big, it was cumbersome. He said with only 100 hours in a year when conditions are good, one cannot afford to waste time. He said he found very few things with this that he couldn't see in a smaller 20 feet telescope. Because the king had paid so much money for this telescope. The king paid almost the equivalent of $1 million to have this telescope built. He felt like he needed to do something to satiate the king, so he said that he discovered 2 moons of Saturn with the 40 feet, Enceladus and Mimas. He actually discovered them with a 20 feet telescope, but he published it as discoveries with the 40 feet to placate the king for spending all that ridiculous amount of money. It was the world's largest telescope for 58 years. It took 40 workmen to build it. It took 2 years to construct the thing. It took 10 people to polish the specula. The mirror in it weighed 2,100 pounds, over a ton. You couldn't take it out of the telescope, so it tended to tarnish. So it constantly needed polishing, and it never gave really good images. Herschel never let anybody else look through it. Only him was allowed to look through the telescope. He never reported the 5th and 6th star of the trapezium in the Orion Nebula. Resolved a nebula in the stars. He saw no spiral structure, M51, nothing, nada. No color in any planetary nebula. He told everybody it gave pretty sharp images, which is not a rousing talk about how good the telescope was. It needed repolishing often, and it needed 2 workmen to even move the thing with him up top. So he did not use it very much, but it was known throughout Europe, and the king loved it because the French were arrogant in their science. And this was something that brought people from France over to England. So the king didn't care whether he used it or not, but it was a good advertising feature. Later in life, Herschel built what he called the 10 feet telescope, 24 inches in aperture. And this was what he called his old man telescope. Said he could get at any object in less than half a minute. He eventually sold this to Lucien Bonaparte in 1814, which was the younger brother of Napoleon. But the optics in this telescope were excellent, excellent. As far as the mirrors go, people are talking about what a wonderful thing the Herschel 400 or the Herschel 2500 objects are. They have no idea how wonderful that truly is. Specula only is about 68% reflective. Our mirrors today, an enhanced mirror is 96%. Most of them are 86 to 88% reflective. These metal mirrors were 68% reflective. And this is the 48-inch, actually 49-inch aperture mirror that used on the 40 feet telescope. And it was a copper tin mix, which is what these specular mirrors were made out of. But being 67, 68% reflective, that meant that his 20-inch telescope was equivalent to a 13.5 inch telescope today. His 40 feet telescope was equivalent to a 27 inch. If you used it in the Newtonian form, where he had two bounces of light off of the primary and off of the secondary, now his 20 feet telescope was down to 9.1 inch of reflectivity. And then he had coal-fired England to deal with and all the humidity in the sky. So yes, he was an incredible, incredible observer. I've observed all 2,508 of his objects. There were some nights with my 24-inch telescope, 90% reflectivity, I had to come back another night to see it because I could not see the object that I knew exactly was between these two stars. Yet Herschel, with his 68% reflectivity in coal-fired England, nailed it the first time it ran through his 15 arc-minute field. He was incredible, absolutely incredible. And not many people know that. The 40 feet required monthly polishing. It changed its form as the temperature changes at night, which is another reason why you didn't use it. Glass mirrors were used only for solar observing because you couldn't point a metal mirror at the sun because it would expand and the images were terrible. So they used glass for the solar viewing, but the glass in those days was not very good, so the images weren't all that great. As far as what some of the objects look like, I'm doing. As far as the 68% reflectivity goes, these are some drawings that John Herschel made with his father's telescope and with his father's mirrors. And I'll start with this one, NGC 1365. That John drew in 1847, and here it is today. Well, you can see the spiral arms, you can see the nucleus. So pretty darn good. But over here, it's kind of where I have a somewhat bone to pick. John Herschel drew M51, and this is his drawing, and it's obviously a spiral structure to me. But yet, William Parsons of the Leviathan of Parsonstown in Ireland gets credit for observing the first spiral structure in a galaxy, M51. And this is the Earl's drawing. But as you can see here, it's NGC 5194, NGC 5194. It looks like spiral structure to me. John Herschel drew that 12 years before the Leviathan, the 72-inch telescope in Ireland, ever looked at it. But yet, John Herschel is not given credit for the first spiral structure in a galaxy. As far as Herschel's observing techniques, this is him looking down the barrel of the 40 feet telescope. He used a hood, a black cloth over his head. He never took his eye from the telescope all night. If a 5th or 6th magnitude star came into the field, he would avert his vision. He would call his observations down to his sister, and she would repeat it back up to him, and he would repeat it back to her. They repeated each observation 3 times to make sure that they got it absolutely right. But the whole time he was looking in the telescope too. He never took his eye out of the telescope, so he didn't want to ruin his night vision. He said he observed looking downward. That's how you normally sit at a desk and you're right. That's the most comfortable way to spend the night. And that's why he had this set up like this, and he used his left eye for observing. He used high powers, sometimes up to 6,500 power, which sounds incredible, but he taught himself how to do that. And he visually observed until dawn if the sky allowed. He would be out there all night observing. And he'd get a couple hours sleep and then start building telescopes. They said on power, when you want to practice seeing, go to Castor, which is a noted double star, and increase the power until the two stars run together. Every time it is tried again, the eyes acquire more practice and can now see with powers the eyes used to reject for a long time. Which I'll get to, but few of us observe surface features on Io, Europa, Callisto, and Ganymede, the moons of Jupiter. He did at those powers, and was able to discern detail, or the fact that they rotated or did not rotate. As far as investigating the causes of which often prevent the proper action of mirrors, surprisingly, he said the best condition was moisture in the air, which those of us hate. But he said he can see double stars with 460 power completely well. Fog, stars stayed distinct and bear considerable power even in foggy weather. That's another thing. You know, it's foggy. You don't want to observe. You know, he loved it. But dry air does not see well. Windy weather is not good. Fine in appearance. This is another thing. When we see stars that look good, we think it's going to be great. Well, he says when stars appear as fine to the naked eye, no telescope will act as well as it should. That's interesting. And over a building, observing over a roof or house gets poor images. And I like this telescope lately brought out. I tried to use his words and his vernacular as much as possible, you know, throughout, and his spelling in some cases. But he said that would not act well. But surprisingly, moisture in the air was his favorite time to his ideal observing. In 1788, Herschel got married a wealthy lady, and she was very good to him. She didn't interfere in his workings. Her name was Mary Pitt, and Carolyn kind of got a little bit torqued about this. Carolyn was no longer the most important female in his life. She moved out. But very shortly thereafter, Carolyn and Mary became the best of friends. But Carolyn never moved back into Slough. She lived down the road. She'd show up at nighttime and do nighttime observing. In the daytime, she had nothing to do. She was kind of a lonely lady. But when Herschel married Mary, he was able to cut back on telescope building because she had enough money that he didn't need to build all of these telescopes like he'd been doing. Shortly thereafter, John Herschel came along, and John was every bit as brilliant as his father. I mean, it's an incredible family. You know, William Herschel was amazing. Carolyn Herschel was amazing. John Herschel was an amazing individual. This is a photograph. This is not a drawing. That's an actual photograph of John Herschel. He was one of the pioneers of photography as we know it today. He was not only an astronomer, but an author, a botanist, a chemist, inventor, a meteorologist, and a photographer. He named 7 moons of Saturn, 4 moons of Uranus. He wrote a book on outlines of astronomy, which was a standard text. He originated the Julian day system. It went back to Julius Caesar. He was knighted at the age of 39, which is an unheard of young age for that. And he was idolized by Charles Darwin. They are buried in Westminster Abbey in tombs next to each other. He also excelled at everything he did, and they said he never had a childhood. He never played. He was advanced at a very young age. Never played games. Never associated with other people his young age. He moved to South Africa, took his father's telescope with him, and this is a drawing of it right here. And he was down there from 1834 to 1838. He observed the entire southern sky that his father could not get from England. And said this was the happiest time of his life because by then this rendered him freedom from being the most sought after man of science in Britain. He had no time to himself. People were always wanting a piece of John Herschel for this, that, or whatever. His discoveries, he discovered 3,347 double stars. He discovered 1,810 nebulae. 1,285 of them were in South Africa. The father and the son combination of the 7,847 840 NGC objects that we all love to look at today, the two of them discovered 5,331 of them, or 68% of the total NGC objects that William and John Herschel discovered. So they were quite prolific. This is a drawing of Saddle Mountain, which is where his telescope was set up. In 2002, my friend Steve Romero was down there and he tried to duplicate the picture, and he sort of did. I mean, you can see this is Saddle Mountain here. The mountain hasn't changed, but this is a school that's here now. It obviously wasn't there then, and of course there's not a telescope there either, but it still looks much the same. John Herschel was an avid photographer. He was into photography as much as astronomy. He coined the term photography. He invented the words positive and negative. He discovered sodium thiosulfate, which was a fixture for developing pictures. And he was first to produce a photograph on a glass plate. And this is the glass plate right here. It's his father's 40-foot telescope frame. He did another thing when he was in South Africa. He employed something called a camera lucida, where they could put flowers and leaves and plants and cast an image of that on a piece of paper, and then they could draw what that object looked like, and then John Herschel's wife Margaret would add the color to it. And this is one of 132 of those botanical illustrations, which was a big hit with everybody at the time. It was better than a photograph. But Patrick Moore said that Sir John may not possess the genius of his father, but his contributions to science covered a far wider range, which they did. He reobserved all of his father's discoveries. He published his own catalog of 2,307 objects. In South Africa, he mapped and cataloged the entire Southern Hemisphere. He authored the general catalog, the GC, and Dreyer added to that the NGC, the new general catalog, which was an addition to the general catalog that John Herschel formulated. 5,097 total objects. And after he died, the general catalog of 20,300 double and multiple stars was issued that he just hadn't had time to publish yet. This is a photograph of him here in older age. So that is a little bit about the setup and the people and all of that. I want to talk now about the about the technology, the science that the man did, and this is what a lot of people just don't realize. He published 127 science published papers, and I forgot to get them. You can get these. It's 2 volumes, and these are all the science papers of William Herschel. And originally, I got a copy from the museum. Amazon, of all people, is now publishing these. They're $102 a piece. But if you want to know about Herschel, and this is in his own writing and his own spelling and his own everything, every paper that he wrote is in here. And it's fascinating reading. And it's basically what I'm going to talk about now. He started out observing what he called periodical stars. We call them variable stars. and specifically Myra, or Omicron setting. At times it was bright, at times it disappeared. And you want to know, why is that? You know, why is this star appearing and suddenly disappearing? And he got to looking at the Flamsteed catalog, which was printed in 1729, and the magnitudes and the positions were so bad as to be useless. So he started work on improving that. The periods of the maxima and the minimum, and how black they got. And he reasoned that the unsteadiness of their light is due to rotatory motion, the rotation of the star with dark spots on the star, and or a small sun revolving around a large opaque body, a double star. Nobody else had thought of it, which you think they would, but they hadn't. And he took that a step further. If there's two stars there, he might be able to use that to determine how far away these stars are by using parallax, using the base of the Earth's orbit as the base of the triangle. And at the time, and this is an example of it. At the time, the thinking was that all stars were about the size of our sun. And the magnitude difference was due to distances alone. In other words, a second magnitude star was twice as far as a first magnitude star. A sixth magnitude star was 6 times further than a first magnitude star, because it had no other way of looking at it, and it made sense. Herschel reasoned that the nearest star, which he figured was Sirius, because he couldn't see Alpha Centaurus, but to him the nearest star was Sirius, and it was 4,000 times the diameter of Earth's orbit, which works out to about 7.5 billion miles. He was so far off, it's not even funny. Sirius is 5.8 trillion miles, is 1 light year, and it's 8 of them. It's about 50 trillion light years away. So he had no idea how big the universe was or how far away these stars are. He said there's 2 things necessary: at least 460 power and an accurate micrometer where you can measure these stars and if they move or don't move or whatever. But the results of this, it took him till 1803 to write this, but he reasoned that relative positions are not attributable to parallax. He couldn't find any double stars that had different parallax between the 2 stars, that a different angle between the 2 stars. And theoretically, a closer star should have a bigger angle, and a further away star should have a narrower angle. He didn't see that in any of them. So he reasoned they're all at the same distance. And beyond that, he saw Castor and Pollux as their position angle changed over time. So he reasoned they circle each other. From that, he deduced that gravity extends beyond Earth to the stars. That was considered revolutionary at the time. His own son, John Herschel, didn't believe it. You know, how can you say gravity extends out there? I see it in the stars. They're moving together. They're gravitationally bound. So there's the first nail in Newton's clockwork God theory. The universe is changing. It's not static. The background does move. Things are happening out there, and this was the beginning. He launched into double star studies for over 25 years. Published 3 different catalogs. The first catalog was interesting. He used powers up to about 6,500 power. His first catalog, he discovered that Polaris was a double star, and he was amazed to find out the people at Greenwich did not know that, which is a testament to how good his optics were, his telescopes were, because they were collimating their telescopes off of Polaris, but they never knew it was a double star until he did his first catalog of double stars. The second catalog of double stars, he discovered Uranus, the planet, or Georgium Sidus. And then he did a third catalog, which he published later in life in 1821. He probably spent more time looking for double stars than he did for anything throughout his life. While he was doing this and building telescopes and staying up all night, he did something that is today considered remarkable. He found which direction our solar system is moving through space. And that's considered today incredible. He used information that existed from Claudius Ptolemy in the Almagest, which was published in 150 AD, and the stellar positions of Maskelyne and the French astronomer Lalande in his own day, and he found which stars were moving in which direction. And he theorized, if I can figure out where in the sky, if I'm going that way, stars are going that way. That's where I'm going. And he likened it to walking towards a forest. As you get closer to the forest, the trees on the left move this way, the trees on the right move this way. You go through the forest, they close in behind you. So where in the universe can I find this existing data, which had been free to everybody? But where can I find that? Well, he found it. He called it the solar apex, and it's near Lambda Hercules, which is near Vega. And today we know that he was off by 10 degrees. He hit it dead smack on. This is information that was available to anyone, but it took the genius of Herschel to come up with it. So that was, and to me, is incredible. He also did a catalog of comparative brightness of stars, determining the luster, which he called it, the brightness of stars. And he did a lot of work on this, and it's interesting work, and I'm going to kind of gloss over a little bit. He was beginning to think that, well, maybe there are stars of different sizes out there that has to do with the luster or the brightness of these stars. This is mostly naked eye observations, and it took him a long time to do this. He published it in 6 catalogs, and this is some of the published material. And 100 years later, Pickering, in checking out what he did, he says he wasn't a tenth of a magnitude off. The reason he did this, and it holds up to this day, he stated magnitudes are too arbitrary. Comparison with nearby stars are best. And those of you that read scientific articles like I do, you can read 6 of them, you can get 6 different magnitudes for the same object sometimes. So that was very good. Magnitudes were too arbitrary then, and still are to this day. So one of the main areas that puzzled Herschel, not anybody else, but puzzled Herschel, and Charles Messier inspired this, and his sister Caroline inspired this as well, finding objects with her small sweeper telescopes. But he said that all objects can be reduced to stars if a large enough telescope is used. And he got that from Messier, who observed with 3.5-inch telescopes up to 7.5-inch telescopes. He said every object in the heavens is of a starry kind. Nebula and telescopic Milky Way. He said if you got far enough away from our Milky Way, it would look milky. And that, yeah, it's full of stars, but the concept is that everything out there was stellar. A nebula did not exist. So self-luminous borrowed light, reflected light from so great a difference would never reach us. These nebulae must be shining from the light of many stars in a globular interacting form. Well, this is what Charles Messier, his view of M13 was. Herschel looked at it with an 18 3/4-inch telescope. Voila, that's what he saw. So that is why all objects can be reduced to stars if a large enough telescope is used. That is what started all of this. And that was also the inspiration for him doing what we all love, the Herschel 400 or the Herschel 2500 objects. He dropped the double star observations. And the day that he was inducted into the Royal Society of England, his friend, Dr. Watson, handed him a copy of Charles Messier's book of his 103 at the time objects called Connaissance des Temps. And Herschel had never seen that before. He looked at it and he came up with a comment, which is probably an understatement of all times. Several nebulae might yet remain undiscovered. And went out and discovered 2,500 of them. And he did this in 3 catalogs. And before that, only 138 objects had been known, but he discovered 2,508 nebulae. This is a page of that observations. He broke it down into 8 separate classes, and he didn't use right ascension. He used the time it took an object to precede a Flamsteed star or follow a Flamsteed star, and then use that by measuring with a clock. He used a polar diameter from either north or south of that star, and then used a wax-covered rope, which wouldn't expand in the weather. It was very crude, and they made a lot of mistakes, but that was the best they could do at the time. But that's how he did it, and this made him famous. Caroline documented everything in sweep books, register sheets, and zone catalogs. And I'm going to gloss over this, but this was an incredible amount of work. The zone catalog was in polar distances down to 121 degrees south, and it was for John's use only. And he never published it because he didn't think anybody could ever see these NGC objects without having a big telescope. This is a plot that I made on his observations at Datchet using the Newtonian form. He did most of his observations in a given time. In 1784, had 104 observing nights. And you can see his interest waned as he went along. He took up Saturn observations, comparative brightness of stars. He only used the 20 feet front view after here. So again, he used the Newtonian form a lot for his observations, not just the front view. He did most of his observations in April, and this is a breakdown by month. And he did about equal observations at Datchet and at Slough. And of interest, on one night, he discovered 70 new objects. April 12th, 11th and 12th, 1785. And it's been called the Herschel Sprint or the Herschel Marathon. And it's a challenge for people to do that, to observe all 70 of these objects in one night now. It's pretty darn difficult. Most of these objects are in Coma and in Leo Minor. That's where most of them are. But this is just a few of those objects. Some of his planetary and solar system observations, and I'm racing because I'm running out of time. He discovered how high mountains were on the moon. They knew that the moon, or reasoned that the moon had a radius of 1,090 miles. If you could take a micrometer and he could measure this distance from the limb to the top of the mountain, then he would have 2 sides of the triangle figure. They could calculate using the Pythagorean theorem the hypotenuse of that, and then the difference in the length of the hypotenuse and the difference in the radius is the height of the mountain. And he came up with the tallest mountain that he found was 120 or 1.25 miles, 1.25 miles tall, which is pretty much what we know of today. The tallest mountain is Mount Huygens, which is a little over 3 miles, but that's in the center of the moon. He also reported volcanoes on the moon that were shot down. Those were Kepler, Copernicus, and Aristarchus. They're very young craters that looked like coal at the time. His Mars observations, and these are some crude drawings that he made, but he knew that the poles were frozen. The size varied due to seasons. He said they were not quite opposite each other. Said he found Mars had an atmosphere, the stars dimmed on approach, and that the surface had vapors and clouds. He also thought all the planets and the sun were inhabited, and the inhabitants probably enjoy a situation in many respects similar to ours. As far as Jupiter goes, he measured the rotation rate of Jupiter. He was off 33.5 seconds. Jupiter's moons, he reasoned that he found out they rotate on their axis and keep the same face pointed towards the planet, because he looked at them at 6,000 magnification, and he could tell the light variation did not change in relation to the planet. As far as the satellites, which he referred to as 1, 2, 3, and 4, satellite 1, the revolution period. And when I say revolution, you're going around as opposed to rotating like this. But the revolution period, he was off 26 minutes. For Europa, 19 minutes. For Ganymede, he was off 36 seconds. And Callisto off 1 hour and 30 minutes. So all of those are pretty much spot on. He spent a lot of time looking at Saturn. He loved Saturn. The rotation of Saturn's disk, which those of you that looked at it, there's not a lot of features on Saturn. He was off 26 minutes on its rotation rate. He was off on the ring, Cassini's division, 1 hour and 3 minutes. And he said there are 2 unequal rings. He noted a shadow. The ring reflects more than the body does. And he said the ring was a solid body. If it was a liquid, it would not stay sharp. The edges would not stay sharp. It had to be a solid body. And he discovered with the 40 feet, the 6th and 7th moon, Enceladus and Mimas. There's Georgium Sinus, Uranus. These are pretty incredible. He didn't know distances, so I've inserted our modern distances. But today, versus what he thought, he was off by 70 million miles as far as the distance goes. The diameter, he knew it was a huge planet. He was off 2,700 miles. Its volume, its mass, he was very close, and he noted the poles were flattened, and due to high rotation rate, and it rotates in 17 hours, but it's 8 times as large as the Earth. So it's rotating at a high rate of speed. He was able to see that and reason it was due to the high rotation. He was never given credit for the rings, but he noticed that stars dimmed before they got to the planet. And he said that there's probably 2 sets of rings. But then in 1798, in a paper that he wrote himself, he says, after 10 years of study, no rings exist. So he was kind of vacillating back and forth. But here's a today's image, Hubble Space Telescope, and here's a drawing Herschel made. Looks pretty darn similar. So he's not given credit for rings, but I think probably maybe he should. He discovered 2 moons of Uranus, or Georgium Sidus, and he said both were inclined 89 to 91%. The rest of the solar system was going this way, these were going this way. He couldn't determine the planet was rotating on its side, but he found out the moons are. He discovered Titania. He was off 2 minutes and 30 seconds in his revolution. He discovered Oberon, and some astronomers think he discovered Ariel as well. And he had multiple sightings of 4 more moons. He did solar observing. He thought people lived inside these openings. The bottom, the umbra, was a solid surface of the sun. The shining matter was what we call a penumbra. And his telescope setup was pretty ingenious. He had what he called a skeleton eye tube, which he plugged into where the eyepiece would go. He put a what we call a trough, put that inside the tube. His eyepiece went in the end here. And then last but not least was his filter. My bottle of wine. And he would fill this trough up with red wine. Sometimes he'd use ink and water, and he could look through that. That was his filter, that he was able to look at the sun without destroying his eyesight. You know, pretty ingenious. He discovered infrared. And he said heat and light were part of the same spectrum. He said if rays are invisible, then they're not light. And he came up with invisible light, which is an oxymoron. And he worked with this for some time, but he finally settled on heat and light were part of the same spectrum. He measured through the breakdown of light. He made the violet was a 2-degree increase. The green part was a little over 3. The red part was 6.9. And out where there was no light was almost 9 degrees. That was his invisible light. So the beginning in 1785, he started questioning why is M13 and M31 different. The large size of M31 and M42 proved they're nearby, but he could not break them into stars. His biggest telescope, they still remained nebulous. He was beginning to suspect that not all nebula are star clusters. And the ring nebula really gave him fits. He never figured out what that was. Is this a bunch of little small stars in a ring? He couldn't figure it out. But this paper marked the opening of the modern era of astronomy. And he did one other thing. He did what's called star gauging. This is his spelling, not mine. But he counted the total number of stars in the field of view, 2,400 fields totaling over 90,000 stars. And he looked here, all over the sky. Where are the most stars? Where are the fewest stars? And he assumed that the closest stars, Sirius, was 412,000 times the distance of our sun. And from that, he was able to get a rough distance estimation. But he came up with the Milky Way here. And the we see the Cygnus split here. And he said that our Milky Way was like a grindstone. And he had our sun placed near the center. The shape was correct. And if you look at our nearby NGC 7331, which looks very much like our nearby, our Milky Way, you can see the resemblance. The sun was in the galactic plane. The sun is all set from the center, but too close. But it took them 150 years to figure out that we really are 27,000 light years out from the center of our Milky Way and not close to the center. This was an astounding body of work that he did between nebula sweeps. This was a huge paper that he wrote in 1791 on nebula stars, and this shook up all of Europe, all of the science community with this. Before NGC 1514, Herschel had never seen a planetary nebula that had a central star. Never seen a central star in the center. And that really got him to thinking. He said, if there is no nebulosity, one of two cases must be admitted. If the nebulosity consists of small stars, which they had previously thought, then what must be the enormous size of the central one? Or if the central star is common, then how small must be the luminous stars which surround the central? And he called this a shining fluid. And he said it was probably similar to the aurora borealis or the zodiacal light. He said it was probably something we'll never understand what it is. But he said gravity is working. And his theory was this star is forming out of this shining fluid. Another nail in Newton's idea of clockwork God. Herschel said we either have a central body which is not a star, or we have a star which is involved in a shining fluid of a nature totally unknown to us. I adopt the latter. He said shining fluid is not reflected light, as borrowed light can never reach us from so great a distance. This one object caused him to modify his views on nebula. He lost interest in a 40-foot telescope when he realized it would never show him nebula that had stars, that nebulosity really, truly existed. And he was big enough to admit his own previous ideas were wrong. He had no problem with that. And his landmark paper was the construction of the heavens in 1811. This absolutely blew everybody's mind. He laid the foundation for modern stellar astrophysics. And he flat out said, when all nebulae could be resolved in the stars, only a telescope of sufficient size were used. Wrong. Absolutely not. There are true nebula which exist. He said, we live in a changing cosmos, unlike Newton's God, the great clockmaker. He said, stars go through a life history, and this is his stellar evolution. The universe begins with widely separated stars. They slowly condense into large conglomerates, the Milky Way. They condense further into globular clusters. They leave behind vacancies like Barnard 86 next to NGC 6520. Those vacancies are where the stars used to be. We call them dark nebula today. These globular clusters evolved into planetary nebula, and that evolved into a star. Nebula are the parents of stars. A new star is formed, and this process repeats. So he summed up the entire stellar evolution of how things work in the universe. He said, a knowledge of construction of the heavens has always been the ultimate object of my observations. And some few more things which I won't read. But this paper, this document dominated astronomical thinking for the next century. Throughout all of Isaac Newton's laws and Herschel's rules dictated for the next 100 years. This was his magnum opus. And it made him beyond famous. His construction of the heavens, this is a few excerpts. He said, nebula are not permanent celestial bodies. The lucid spot in Orion, the nearest nebula, has changed, which he perceived he saw changes. And then from 1659, when Huygens drew M42, to 1811, when Herschel drew it, he said, if it changed, it couldn't be stars. It has to be nebulas. Stars with atmospheres have a shining fluid, which is condensing and forming a star. Herschel was the first to note that nebula galaxies, as we call them, tend to cluster, which had never been thought of. And his island universe theory about being the universe shaped like a grindstone was just revolutionary. And he said the solar system is part of this larger island universe. None of these ideas had even been considered before William Herschel came along, not even thought about. He extended the boundaries of the universe much further than anyone had previously thought by a long shot. So some of the major accomplishments. Before Herschel came along, the Milky Way was the entire universe. It was static and unchanged, a clockmaker-like dome rotating endlessly around the solar system. This one man came up with the largest telescope, the finest specula that had ever been made. He built the largest telescope in the world. He discovered a planet which had not been discovered since prehistory. He discovered 2 moons of Saturn and 2 or 3 moons of Uranus. His reviews of the heavens, his double star catalog was an amazing amount of work. His periodical star studies, his catalog of nebula and star clusters, 2,508 objects, comparative brightness of stars, his planetary moon and solar studies, infrared discovery, proper motion of the sun and the solar system, the solar apex that I talked about, star gauging, and his construction of the heavens. All of this one man did. These are our famous people here, not to take anything away from them because they're all amazing individuals. But Hamilton Hart was his redshift, theories. Hubble, his expansion of the universe. Lowell, Mars, Sandage, galaxies, Tombaugh, Pluto. They did a wonderful amount of work. They did one thing, and they were noted for it. This one man did all of this. And he did it in a way that no one had ever done before or even imagined. So a final thought, Herschel would have loved to be here now as we are enjoying it. It says, clearly the best of times to be alive is when you start out wondering and end up knowing. There is only one generation in the whole history of mankind in that position. And you guys probably guessed it, us. We're very fortunate to be astronomers, to be interested in astronomy. William Herschel would have given his right arm to know what we know today. And you have to wonder, what are people 100 years from now going to look back on our knowledge today? Somebody may be giving a similar talk about the poor people back in 2023 that had to live with all this primitive equipment and ideas. But anyway, I hope you guys can appreciate why Herschel is considered today the father of modern astronomy. He was a major proponent. The universe is not clockwork in nature, but evolutionary. Johann Louis Emil Dreyer in 1912, when he compiled the NGC and index catalogs, wrote, "No earthly monument is wanted to perpetuate the memory of the man who, solely guided by his genius and his energy, rose to the greatest eminence in a hitherto almost unexplored field of science, and widened the horizon of man to an extent no one had imagined possible before his time." That's very true. And with that, I thank you guys. And
You're good.